So far we have focused on how to compute consumer surplus and the change in consumer surplus for situations in which basically the consumer is free to buy in the market at a particular price. But we want to be able to understand the impact on the well-being of the consumer of more general situations and more general changes in situations. And I want to be very precise about what I mean about this in a second. So we want to extend the notion of consumer surplus. And here's how we're going to do it. We're going to call the consumer surplus at a situation theta. And I'm basically using the word theta to denote the features of the consumer problem. It's a complete description of what affects the consumer problem. So before, for example, we're calling consumer surplus of P because we were indexing by P the budget set and the consumer problem at price P. But you will see as we go through this video that there are many other situations of interest. And we're going to have a very similar notion as before. The consumer surplus at situation theta is just going to be the utility, the experience utility that the subject gets when it takes the optimal action given the decision problem or situation theta that it faces, minus the utility of the no trade situation, i.e. when he is just basically at its initial endowment of consuming no X and W. As before, this has a nice interpretation, is just the net change or gaining utility from taking the optimal action at theta, at situation theta. Okay? So it's exactly the same idea. I hope this is clear, except that now we're going to look at more general classes of situations. Let's look at a concrete example to make this more intuitive and precise. So let's call or consider a situation theta, which is one that we have encountered before, in which the consumer decides how much to buy at price P, but he faces a constraint, which is that he has to purchase at least 1 unit. So X, the X over which he can choose, has to be greater or equal than 1 unit. And just so we can build on the example from before, let's assume that the utility function for the consumer over X and M is equal to 2A square root of X. Now, what we want to do is ask what is the consumer surplus in this particular case for different thetas that are characterized for different P, by different prices. Okay? Now, in order to solve this, it's useful to also remind you of what the consumer surplus look in this case, sorry, there's a plus M here, in the case in which there was no minimal constraint. So we knew that for this example, the consumer surplus at P was given by A squared divided by P. We solved that before, and we also know that X star of P was equal to A squared divided by P squared. So we are going to use that in a second. Now, to start computing the consumer surplus of theta, we need to understand what does X star at theta looks like. And we have actually solved that before. We saw that if this was the marginal benefit function, which in this case is A over square root of X, and remember this is X, and this is a 1 unit, and this is A, P equals A, then we saw before that the X star of theta basically look like this. When the price is low enough, you're here, and when the price is high enough, you become constrained and you are there. So what have we learned here? That X star of theta is equal to 1 if the price is greater or equal than A, and otherwise is just as before, is given by A squared divided by P squared if the price is less than A. Now, basically, I hope that you remember the intuition from before. This is quite intuitive. If the price is low enough, you're not constrained, and you do what you would do in the absence of the minimal purchase constraint. But when the price gets high enough, you become constrained, and you are at that point. Now, we're ready to compute what is the consumer surplus at theta. I'm going to show you in a second that is also a function that depends on the price. So it's going to be something where the price is greater or equal than A, and something else when the price is less than A. Now, an easy way of understanding what this function looks like is to actually plot consumer surplus versus the actual price. And the first thing to notice to characterize the consumer surplus is the following. If the price is below the price A, so if we are in this region of the price, the minimal purchase constraint does not bind, so you demand exactly the same amount that you did before. And what happens then is, since you are demanding the same amount and you're not constrained, your consumer surplus has to be exactly the same. So if I plot here the function A squared divided by P, which is equal to your consumer surplus without constraint, we know that at theta, up to the price A, the consumer surplus of theta is going to be there. So we know that when the prices are low enough, it's just as before, this is A squared divided by P. Now here comes the interesting question. What happens for higher prices where the constraint actually bites? Notice to derive that one thing, which is when the price is A, if you substitute the formula, you get a consumer surplus of A squared divided by A, so the consumer surplus there is A. Now, this is the key tricky part of the problem, so I'm going to do it very slowly, very carefully, and it's very important that you pay very close attention to this. Now, what happens when you are in this region of the price for prices greater than A? Okay. Now, you're going to be consuming 1, but you're not going to be paying the price A that gets you to demand that. You're going to be paying a higher price. Let's say this higher price, P. Okay, and this distance, let's call that P minus A, which is a positive number. Now, your consumer surplus when the price was A was given by exactly this area, which was, of course, all of the area under the marginal benefit function minus the price that you paid for it. We've seen that several times so far. Now, what has changed? You still get to consume 1 unit, so you still get that, but now you have to pay all of this price instead of only that. So your costs have gone up by, I'm going to use another color, that rectangle looking thing. And what is the area of that rectangle? The area of that rectangle is 1 times this height, P minus A. So what do we know? We know that the surplus in this area is going to be A minus P minus A. And if you do the algebra, we can substitute that as 2A minus P. Now, let's go back to the plot and see what happens. If you had not been constrained, your consumer surplus would have been over here and would have always been non-negative, because you are free to choose, and you're only going to choose to buy something if it's better than the consumer surplus of 0 that you get at the initial endowment. Now, but what happens here is that once in the new situation, the situation theta, once the price goes above A, your consumer surplus starts going down linearly, something like this. And in particular, it's interesting to know that it crosses at 2a. You can do the algebra yourselves. I want to highlight a very important lesson that this example teaches us. We saw before, I'm going to highlight it here in a square. We saw before that CS of P was always non-negative. That is basically when you compute the consumer surplus for just choose how much to buy at price P without constraints. Notice that CS of theta may be less than 0. So there are other situations, like for example, being forced to buy at least 1 unit when the price is out there, in which you may end up having a negative consumer surplus. What does that mean? It means that if you could, you would rather not do anything in this situation and just consume your endowment, 0 units of X and W units of M. But you have to take an optimal action given the constraint. That optimal action, for example, when the price is very high, let's say here, leads you to buy 1 unit, and that is associated with a negative consumer surplus. It's negative, but it's the best you can do. So, key lesson, in general, the consumer surplus may not be positive if you are in situations in particular in which there are these types of constraints that may lead you to do things that you would naturally not want to do.